The desert wind carried the smell of burnt metal and oily dust. In February 1943, at Sidi Bou Zid, Tunisia, an American tank was left behind among the dunes after the chaotic retreat of Allied forces. As German soldiers approached, they noticed the White Star emblem still intact on the hull, with traces of gunpowder burns not yet erased. Beneath the layer of yellow dust, the name War Daddy 2 appeared, with the serial number USA 3067641 engraved deeply into the steel shell. It was an M4A1 Sherman belonging to Company G, 1st Armoured Regiment, a rare prize because it was intact and operational. For the German engineers, it was a gift of fate, and they did not yet know that this gift would shake the industrial faith of an entire empire. When the machine was restarted, the sound of the Continental R975 engine echoed not hoarse and dry like the Maybach of the Panther, but round, steady, and strangely smooth. An officer recorded in his diary, "The engine sounds like a tractor, but it doesn't stop." The reconnaissance unit was ordered to drive the Sherman toward the port of Sfax, a 350 kilometers journey through sand, rock, and temperatures above 40 degrees Celsius. The march lasted 4.5 days without any mechanical failure. According to the internal report of Panzergruppe Afrika, they had to stop only 3 times, twice for refueling and once for rest. No gear broke, no system overheated. For men used to seeing Panthers stall in the middle of the road, this was almost absurd. On the 4th evening, when the Sherman rolled into the harbour, its headlights reflecting off the oil-slicked steel, the German mechanics stood silently watching. An old sergeant from the motor pool muttered, "An American vehicle that can go this far." In the cold, dry air of the Tunisian night, the steady engine throbbed like breathing. And within that rhythm, German confidence began to crack. In his report to Berlin, Major Hans Lütke of the Field Engineering Department wrote, "The radial air-cooled engine is simple in structure, yet effective. The transmission system requires no frequent adjustment." The report was sent to the Ministry of Armaments and reached the desk of Albert Speer, who had just replaced Fritz Todt as Minister of Armaments and Munitions. According to an archival document at the Bundesarchiv, Speer's handwritten note in the margin consisted of only 2 words, Seltsam solide, strangely solid. When the transport convoy prepared to ship the Sherman to Europe, engineers from the Heereswaffenamt, Army Ordnance Office, requested that the vehicle be kept as it left the battlefield. They wanted to dissect it like a living organism without changing the oil, cleaning, or erasing traces. The ship carrying the Sherman left the port of Sfax in mid-February, heading for Naples and then across the Adriatic. In the technical log, a note read, "Vehicle must arrive in Germany intact, not disassembled, not stripped of markings." On the ship's deck, amid the Mediterranean wind, young Waffenamt engineers gazed at the Sherman under its tarpaulin. One joked, "If it makes it to Berlin, we should shut down Maybach." The group laughed, but the laughter had a strained tone. They had never seen an American engine endure such a long journey. According to the 9th Army Workshop statistics, a Panzer III typically required maintenance after every 90-120 kilometers of marching. For the Panther, after just 80 kilometers, the final drive risked failure. Yet this Sherman had travelled 4 times that distance in silence, as if it did not know the meaning of fatigue. When the ship docked in Naples, a transport lieutenant reported that the entire system was still operational. They tried to start the engine, it roared to life on the first attempt. The report sent to Berlin stated, "No sign of oil consumption. Operating temperature stable at 85-90 degrees." The report was short and cold, but it made many in Kummersdorf frown. In Maybach's production workshops, mechanics were hand-fitting each pair of gears. Every gearbox required 43 hours of machining, and even then could fail in the field due to a 0.02 mm misalignment. In Berlin, Speer called an emergency meeting. On the large map spread across the room, he placed his finger on Tunisia. "What did they capture?" Speer asked. An officer replied, "An American tank, sir, and it still runs." Silence filled the room. Speer nodded slightly and ordered, "Bring it to Kummersdorf. We will see where the Americans have truly surpassed us." On the 10th of March 1943, a special train left Naples carrying the Sherman under heavy cover. On its hull, new black letters appeared. Versuchsfahrzeug 259, wage 058941. The train travelled through the night, across the Alps, through Munich, and stopped at Brandenburg. According to the Kummersdorf log, the vehicle arrived in mechanically perfect condition. The next morning, when the cover was pulled away, a group of German engineers stood in a circle around the tank. In the cold, dry air, pens scratched across notebooks. A young engineer named Kurt Meissner wrote in his journal, "Hull thickness 50, 1 mm, welded not cast, yet the weld seams are so firm we thought it was a single piece." He paused, looking up at the faded American star. Something about this machine made the Germans feel as if they were facing the illusion of their own making. According to the Kummersdorf report of March 1943, the Sherman was mass-produced with low precision but high operational durability, using standardized components. In the notes section, Chief Engineer Oberingenieur Franz Adler commented, "The Americans do not aim for absolute precision. They only require that it works under all conditions." That sentence was underlined twice. In the afternoon, when the team started the engine for the first time in Germany, the sound filled the misty courtyard. A soldier chuckled softly, "It's alive again." And within that laughter was something like confusion, for they understood that what they were witnessing was not merely a well-functioning American tank. They were witnessing the seamless operation of an entire industrial philosophy they had never believed was necessary. Speer arrived at Kummersdorf 3 days later. He stood with folded arms, silently observing the team examining the air cooling system, the herringbone transmission, and the 5-speed synchronized gearbox. No one spoke. Only the hum of a 16mm camera from the technical film department could be heard. Speer turned to his aide and asked, "Do you know what this means?" The man replied quietly, "Sir, they have manufactured reliability as a standard." Speer pressed his lips, gazing into the foggy sky. "And in that silence," he said, "the future of German industry began to waver." As dusk fell, the Sherman still stood in the yard, its grey paint covering the white star, the old emblem replaced by the black cross of the Wehrmacht. Under the dim yellow light, the steel reflected a cold, alien glow. And there, in the silence of the desert that had brought it here, the pride of German engineering began to fracture. The March morning in Brandenburg was cold and dry, with a thin mist covering the ground like a layer of grey glass. Kummersdorf did not resemble a war testing site, but rather a vast research institute, a place where reason was worshipped, where every screw had to meet exact specifications. Since 1870, this place had been Germany's most secretive technical centre. After Hitler came to power, it became the mechanical brain of the Wehrmacht, with more than 20 laboratories, 10 test tracks, and its own railway network. Inside the 3-metre-high steel fences, German engineers believed they were redefining the concept of perfection. When the Sherman from Tunisia was brought into the central yard, that belief began to falter. According to records from the Heeresversuchsanstalt Kummersdorf, the tank was assigned the code Versuchsfahrzeug 259 and the license plate WH058941. The engineers in the inspection team wore leather gloves and white lab coats, moving around the vehicle like surgeons preparing for an operation. They placed measuring tools on the steel hull, recorded the 51-degree slope of the front armour, and frowned slightly when they noticed the welds were even and deep. "No burrs, no misalignment," engineer Kurt Meissner wrote in his notebook. "Yet this welding structure does not require the precision we normally insist on, and still it is very solid." He looked up at the smooth grey shell of metal, feeling as though he were examining a living organism from another civilization. In test building number 3, the transmission specialists disassembled the gearbox first. The internal structure puzzled them. 5 forward gears, 1 reverse, with herringbone gears intersecting into a V shape. There was little need for fine grinding, no use of ultra-hardened steel, yet when rotated by hand, the friction was distributed evenly. An older engineer looked up and whispered, "They accepted less precision in exchange for durability. That goes against every principle we've been following." According to Mechanical Report No. 214 divided by K, the test team concluded that this design allows operation by personnel with minimal skill, reducing errors caused by human factors. At noon, they proceeded to measure the air cooling system. The Continental R975 radial 9-cylinder engine started quickly even after thousands of kilometers of use. The temperature rose steadily, with no strong vibration. According to the recorded data, the technical report stated, oil temperature stabilized at 90 degrees Celsius, with a deviation of 2 degrees Celsius over 45 minutes. Engineer Franz Adler, head of the engine group, stood silently watching the pressure gauge. He had once been one of Maybach's designers, believing that Germany's water-cooled engines represented the pinnacle of mechanics. Yet before him, an air-cooled machine ran smoothly, no overheating, no power loss. In his notes, Adler wrote, "It seems that what we deemed crude has turned out to be intelligent." In the afternoon, they moved on to test the power transmission system. The shafts connecting the engine to the drive wheels operated smoothly, even without the sophisticated shock-absorbing sleeves used on the Tiger. A young engineer asked, "Why doesn't it vibrate?" Adler replied, "Because they tolerate greater deviations but compensate with flexible materials. We, on the other hand, use steel that's too rigid." His words silenced the room. Another quietly said, "So they designed for real people, while we designed for ideal machines." According to the inspection report, dated 13 divided by 3 divided by 1943, after running on the 2.7 kilometers internal dirt track, the Sherman achieved an average speed of 38 kilometers per hour, with smooth gear shifts and no need for double clutching. The driver, Sergeant Erich Blumer, accustomed to the Panzer IV, said after the test, "I felt less like a tank soldier and more like a truck driver." The remark was recorded in the summary report and soon circulated in the testing ground. It made many laugh, but behind the laughter was unease. For an entire week, they dismantled each component, measured wear, and compared them to German vehicles. One discovery shocked the engineers. All bolts and washers were standardized and interchangeable. According to the report dated 17/3, approximately 85% of Sherman components can be interchanged with other tanks of the same type. In Germany, this rate is less than 30%. A young engineer noted, "We are losing not in technology, but in assembly capability." On March 18, in the Kummersdorf auditorium, the engineering team presented its preliminary results. Behind the rows of brown leather seats sat officers from the Armaments Ministry and representatives from Henschel, Maybach, and Krupp. When the slide displayed the image of the herringbone gears, Adler explained, "The Americans manufacture hundreds of thousands of these each month. They don't grind each tooth, they press them into shape." A man from Krupp frowned. "That lacks craftsmanship." Adler replied slowly, "But it runs longer than ours." The entire hall fell silent. According to archived minutes, the meeting ended in silence, broken only by the scratching of pens. That evening, Meissner wrote in his journal, "We call ourselves masters of precision, but perhaps precision is what's killing us." He recalled the feeling when he started the Sherman that morning, the even hum of the engine, the faint smell of oil from the warm air. "A machine that forgives mistakes, and that's why it survives," he wrote. In the dining room, several engineers sat quietly. One scoffed, "They build theirs for farmers to drive, while ours require mechanics trained for 3 years." Another replied, "Because we see machines as art." The words hung in the air. Outside, the snow melted. Lights reflected off the Sherman's cleaned hull. The grey paint shimmered like human skin, cold and moist. The next day, Speer sent a telegram ordering continued durability tests and comparison with the Panther D. He wanted precise data. According to Technical Memo No. 47/43, the test group recorded, "After 100 kilometers of continuous operation, there were no failures in the gearbox, steering, or final drive. The engine maintained 97% of its power output." That figure forced Speer to admit, "They have built something we cannot break." Kummersdorf grew quiet in the days that followed. The engineers spoke little. Each was occupied in his room, reviewing blueprints, comparing every detail between the Sherman and the Panther. A sense of inferiority crept into every gesture. One evening, Adler walked across the yard and heard the wind whistling through the American tank's hull. He stopped, placed his hand on the cold steel, and murmured, "Perhaps we've forgotten that war doesn't reward beauty, but survival." Or, according to the report sent to the Armaments Ministry at the end of March, the team concluded, "The Sherman's design results from a philosophy of mass industrial production, quick to build, easy to repair, long-lasting in operation. Meanwhile, our designs demand highly skilled labor and constant maintenance." The report recommended studying American production methods, but most copies never reached the factories. Many high-ranking officers considered it a document that undermines morale. At the end of the month, Speer returned to Kummersdorf. He entered the testing hall, where the tank lay half dismantled. Gears, crankshafts, and pistons were scattered across the floor. "What have you found?" he asked. Adler replied, "A machine that endures." Speer looked around and said quietly, "Then we've lost to a philosophy, not a battle." That evening, fog covered the road, leading out of the testing grounds. The sound of trucks rumbled away, carrying boxed components. Behind them, the Sherman still lay there, its body unassembled. Under the dim yellow light, it looked like a patient after surgery, silent and breathing evenly. In that moment, Kummersdorf was no longer a testing facility, but a clinic for the entire German engineering psyche. And there, among those who once believed they understood all of mechanics, uncertainty had quietly taken root. On a late April morning at Kummersdorf, the air was still covered in mist. In Test Hall No. 4, 2 tanks stood side by side, a newly assembled Panther D from Mann's production line, and the Sherman War Daddy 2, its body repainted in Wehrmacht grey. The scene resembled two philosophies facing each other in the same room. The Germans stood silent, believing the Panther to be the pinnacle of German engineering, a Maybach HL 230 engine, 700 horsepower, a ZF AK-7 -200 gearbox with 7 speeds, and gear precision measured in thousandths of a millimeter. The Sherman, powered by a Continental R 975 engine with 400 horsepower, a 5-speed synchronized gearbox, lighter materials, and an older, cheaper design, was, in their minds, inferior. But after 2 months of testing, that belief began to collapse. According to Dynamic Test Report number 312 divided by K, the Sherman covered a total distance of 2,047 kilometers before requiring major maintenance. The data was written in red pencil. No significant oil loss, no overheating, no power reduction. Under the same conditions, according to Gruppe Maybach's records, the Panther had to stop for inspection after 480 kilometers and suffered final drive failure at 650 kilometers. Another Panther tested on May 2 travelled only 132 kilometers before the steering shaft broke. Chief Engineer Franz Adler wrote in the report, "The discrepancy cannot be explained by statistical deviation." In the technical conference room, a chart hung on the wooden board. The red bar represented the Sherman, the blue bar the Panther. The average durability of the American drivetrain was 4 times that of the German one. "What is remarkable," Adler said, "is that the American vehicle was not made of better materials. It is durable because its design tolerates errors better." He used the word tolerant, a concept foreign to German engineering. When the meeting ended, no one spoke further. They left in silence, as if forced to swallow something unacceptable. According to the Armament Ministry's report from May 1943, the first summary stated clearly, "The American M4A1 tank achieved performance and durability exceeding all current standards of the Third Reich." A copy was sent to Berlin. Speer read the report that same night. According to his aide Rudolf Scheid's notes, Speer folded the papers, sat for a long time by the window, and whispered, "We will not publish this. The spirit of the engineer must be preserved." The next day, an order was issued. All Sherman test data was to be classified, marked NFI, nur für internen Gebrauch. But the truth could not be hidden forever. In internal meetings, engineers discussed and exchanged figures they dared not record publicly. A young engineer from Henschel asked, "If they build this on an assembly line, and we assemble by hand, who is the true master?" The question hung in the air. Oberingenieur Adler replied only, "The master is the one who builds something that lives longer." On May 14, the joint endurance test began. A Sherman and a Panther ran side by side along a 10 kilometers rough track on the outskirts of Kummersdorf. According to record number 15/43, the Panther slowed after 4 kilometers, with oil temperature reaching 120 degrees Celsius, while the Sherman remained steady at 92 degrees Celsius. When they returned to the workshop, the Panther needed its bearings replaced. The Sherman only needed dust wiped off. A cameraman later recalled after the war, "We thought we would film the Panther winning, but the camera only caught the Sherman moving on." That image, a few seconds of silence in the test footage, was the moment the Germans realized they had built an idol of glass. The crisis spread within. Engineers who once believed in absolute precision began to question their own technical education. Meissner wrote in his notebook, "We teach students that error is the enemy, yet the Americans have made error their ally." These words were copied in many notes after the war. The keyword tolerance appeared for the first time in German technical documentation in 1943, a sign that the mindset had begun to crack. In the engine workshop, engineer Kurt Meissner compared the weight and structure of the two machines. The Maybach HL 230 weighed 1,200 kilograms, with 12 water-cooled cylinders, requiring maintenance every 100 operating hours. The Continental R 975 weighed only 580 kilograms, air-cooled, with maintenance every 300 hours. "Half the weight, triple the lifespan," Meissner wrote. According to data from the 9th Air Force Technical Report, the same type of engine used in BT-13 trainer aircraft had operated over 400 hours without major failure. The German engineers exchanged bitter smiles. They had underestimated American civilian industry, and now that very industry was teaching them a lesson. On May 20, Speer visited Kummersdorf for the second time. He walked slowly around both tanks, touching the Panther's armor smeared with oil. An engineer reported, "The Panther requires 45 man-hours of maintenance for every 100 kilometers of travel." Speer looked toward the Sherman and asked, "And this one?" Adler replied, 12 hours, sir, with untrained labor." Speer said nothing more. As he left the workshop, he spoke only one sentence. "Simplicity has defeated us." According to the 1943 Maintenance Statistics Report, Panther tanks on the Eastern Front had an average service life of 1,000 kilometers, while the Sherman exceeded 3,000 kilometers under the same conditions. When this discrepancy was presented before the Wehrmacht Technical Committee, many were so shocked they claimed the data had been tampered with by the Allies. But cross-checks at Kummersdorf confirmed the figures were real. A lieutenant colonel on the committee said, "We did not lose for lack of steel, but because we did not understand what steel was for." In the days that followed, the atmosphere in the test facility grew heavy. The engineers worked quietly, but all knew they were facing a dangerous truth. Each time Sherman's engine started, the entire workshop paused to listen. The sound was steady, deep, carrying an uncanny sense of stability. An old engineer murmured, "That is a sound we never achieved." Oh. According to Meissner's post-war memoir, one afternoon he and Adler stood in the test hall watching the Sherman drive across the yard. Adler said, "We always thought precision was the soul of German engineering, but perhaps, in seeking the soul, we have killed the body." Meissner recorded the words exactly. At the end of May, the final report was sealed. The last line of the original document read, "The M4A1's stability and fault tolerance demonstrate superiority, reflecting a philosophy of mass industrial production rather than fine craftsmanship. Recommendation: keep data confidential." Below it, Speer signed, his stroke firm. But those working at Kummersdorf could not remain silent forever. Some copies leaked to technical schools. In an internal lecture at the Technical University of Berlin in June 1943, Professor Hans Niebel told his students, "Sometimes, a machine that endures is more important than a machine that fights." His words silenced the entire hall. Summer came, and the forests around Kummersdorf turned green. Each morning, the sound of Sherman's engine echoed steady as a heartbeat. In the workshop, the engineers continued taking notes quietly, but in their eyes, the pride of German engineering was no longer intact. They knew the truth, yet none were ready to accept it. An industry that had believed in absolute perfection was now confronting its greatest paradox. Perfection had become the trap. And in the silence of Kummersdorf, as the afternoon light fell upon the grey steel hull, one could hear the smallest yet clearest sound of that era, the sound of pride cracking. In June 1943, the Hillersleben testing centre in central Germany became unusually lively. From early morning on the 6th, dozens of trucks carrying guests lined the roads, RAF flags fluttering against a gloomy sky. This was not a parade, but the National Armaments Engineering Conference, where Minister Albert Speer demanded the display of Germany's newest tanks as well as captured Allied vehicles. Among the list was one name that surprised many, M4A1 Sherman, captured intact, Tunisia. According to Vertechnische Amt document No. 77/1943, Speer wanted to personally witness the performance of the Sherman that had puzzled engineers at Kummersdorf for 2 months. Beside it stood the Panther Ausf. D, weighing 45 tons, the new pride of the Wehrmacht, and the Ferdinand Elephant, a 65-ton self-propelled gun produced through a collaboration between Porsche and Krupp. On the grandstand were hundreds of engineers, generals, and factory representatives. Among them were those who had helped design the Tiger, men who still believed that German engineering set the world standard. The demonstration began at 9 a.m. The 3 vehicles were ordered to climb an artificial slope nearly 30 meters high, with a 32-degree incline covered in damp sand. The Sherman went first. The driver was Test Sergeant Erich Blum, the same man who had operated the vehicle at Kummersdorf. The Continental R975 engine growled softly. The tank advanced smoothly, its tracks digging deep into the sand before cresting the hill in less than a minute. No roaring, no smoke, no hesitation. When the Sherman stopped at the top, Speer nodded, his face expressionless. Next came the Panther. The Maybach HL 230, 700 horsepower, roared, blowing out black smoke behind it. At first, the tank climbed quickly, but halfway up, its speed dropped noticeably. A strange sound rang out. The tracks slipped, and the vehicle stalled. Engineer Franz Adler, standing below, noted, "Oil pressure dropping, gearbox slipping." After 3 attempts, the Panther reached only 2/3 of the slope. The audience still applauded, but no one could hide their unease. When it was Ferdinand's turn, the noise shook the entire field. The 65-ton giant, touted as a mobile fortress, moved only a few meters before a mechanical screech echoed, and the engine abruptly shut down. According to Technische Dienst records, the electrical transmission system had overloaded. A lieutenant from the maintenance unit bowed and reported, "Complete fuse replacement required." Speer turned to Adler, his eyes cold, a product of Porsche's genius. Adler remained silent. On the grandstand, the applause had stopped. In the summary report sent to the Armaments Ministry 3 days later, Speer wrote, "Sherman completed the terrain test without damage. Panther achieved average results. Ferdinand failed." The final line was underlined in red. "American performance demonstrates remarkable stability." According to the archives, Speer privately told his aide, "They manufacture, we compose, and war demands manufacturing, not composing." On June 27, Das Reich published a 2-page article titled modestly, "Ein bemerkenswertes Erzeugnis nordamerikanischer Industrie," a remarkable product of North American industry. The article, written by the Armaments Ministry's press team and approved by Speer line by line, used a neutral tone, acknowledging that the Sherman operates smoothly and is easy to handle, describing it as a notable achievement of North American laboratories. But beneath the diplomatic phrasing, Speer knew it was a warning signal. The article ended with the sentence, "Its simplicity is precisely what forces us to reflect." In Berlin, copies of the article were posted in manufacturing workshops. Many engineers gave a strained laugh upon reading it. One scribbled in the margin, "If the newspapers must praise the enemy, it means we are losing." The mood within the technical community shifted noticeably. According to Kurt Meissner's memoirs, that afternoon after the demonstration, he saw many colleagues sitting silently in the canteen, no one speaking. "I looked around," he wrote, "and realized that each man was comparing what he had built with what he had just seen." On June 30, a closed meeting was convened at the Armaments Ministry. On the table lay the Hillersleben results statistics on range, fuel consumption, durability, and maintenance intervals. Sherman, 2,000 Kilometer between overhauls. Panther, 500 kilometers. Ferdinand, 200 kilometers. The numbers spoke for themselves. Speer finished reading, set the folder down, and said, "We can no longer compete through ideals. We must learn to think as they do." But no one replied. According to the secretary's notes, the silence lasted nearly a full minute, heavy as the acknowledgement of defeat. After the meeting, Speer returned to his office and called Oberst Heinz Guderian, who was then overseeing the Panther program. Speer said, "The problem isn't with the steel, but with how we use it." Guderian replied, "Our steel is better, but their drivers have more confidence." Both men fell silent. In his post-war memoir Erinnerungen eines Soldaten, Guderian wrote, "The Hillersleben demonstration was the moment we understood that German engineering had lost the human element." According to Waffenamt internal records, after the conference, the Kummersdorf engineering group was ordered to draft a full analytical report, re-evaluating the philosophy of German tank design. In the introduction, Adler wrote, "Our problem lies not in design, but in thought. We pursue perfection to the point of forgetting that the battlefield demands survival." The report was 64 pages long, but circulated only internally, stamped Geheim. One officer who read it scribbled in the margin, "This is no longer science, this is confession." In his 1951 memoir, Meissner recounted that evening he and several colleagues sat together in the Hillersleben dormitory. Outside, light rain fell, droplets pattering on the tin roof, mingling with the distant metallic sound of the Sherman being moved to the storage yard. "We looked at each other," he wrote, "and everyone knew we were standing in a historical moment, when those who once believed in absolute perfection realized they had gone too far." The next day, Speer left Hillersleben, driving back toward Berlin. Along the way, he looked out the window and saw trains carrying freshly produced Panthers rolling eastward. "Beautiful, powerful, and fragile," he said to his driver. As the car disappeared, a technician standing on the platform watched it go and murmured, "And in that silence, German engineering just lost faith in itself." The Hillersleben demonstration ended with polite applause, but in the hearts of those present, it was the sound of a death knell. From that day on, they understood that war was no longer a contest between machines, but between philosophies. And at Hillersleben, in June 1943, Germany had been publicly defeated before the world. When the Kursk offensive began in July 1943, the first figures sent back from the front left many engineers in Berlin speechless. According to the Panzertruppen report of August 1943, out of more than 200 Panthers deployed, only 16% were operational after the first week. Most of the tanks were lost not to enemy fire, but to broken drive shafts, leaking cooling systems, or jammed gearboxes. A technical officer of the 10th Panzer Division wrote, "We lose tanks not in battle, but on the way to battle." When this report reached Speer, he only stared at it in silence, offering no comment. The engineers at Kummersdorf understood that those numbers were not tactical failures, they were a verdict against their own manufacturing philosophy. Meanwhile, across the ocean, the 9th Air Force Technical Bulletin recorded that the Sherman had an average combat readiness rate of 72–81% across all theatres. In Italy, the number was even higher, up to 84%, thanks to mild climate and regular maintenance. The difference was not in the laboratory, but on the battlefield. According to Wehrmacht internal reports, by May 1944, the maximum operational rate for the Panther reached only 78%, and that was considered a major achievement after numerous upgrades. Speer called it a temporary victory of data, but he knew the Americans had reached that level back in 1942. The engines told an even harsher truth. The Sherman's Continental R975 had an average lifespan exceeding 3,000 kilometers, while the Panther's Maybach HL230 lasted only 700 to 1,000 kilometers. That number appeared in the March 1944 report of Generaloberst Heinz Guderian, with a note: "This is an acceptable standard." That acceptance was a moral defeat. On the copy sent to Speer, his handwritten remark in the margin read, "We are celebrating catching up to their 1,942. On the Eastern Front, the winter of 1944 was brutal. The Maybach engines failed to handle the cold. Many tanks would not start. The Sherman, according to the 2nd Guards Tank Army report, continued to operate at -20 degrees. The M4A2 diesel models sent to the Soviet Union under the Lend-Lease program crossed mud, snow, and ice without overloading. A Soviet commander wrote in his diary, "It runs like a truck, and we trust it like a companion." German engineers read the translated line in their meeting room. No one said a word. In early 1945, Operation Nordwind in Alsace provided a real-world example that no one could deny. According to the 10th SS Panzer Division report, in January 1945, German forces captured 12 Sherman M4A3S near Hillersleben, all in running condition. Instead of dismantling them, they were immediately assigned to the 13th Company of the SS Tank Regiment. These Shermans were used throughout the operation, travelling hundreds of kilometres without incident. Meanwhile, the Panthers often broke down en route due to overloaded transmissions. An SS officer wrote in his diary, "We drove American tanks to fight American tanks, and the American tanks won on both sides." After the war, researchers found repair records in Strasbourg. Throughout the Nordwind campaign, not a single Sherman required an engine or gearbox replacement, only oil and track changes. In the same area, the Panther unit lost 9 tanks to mechanical failures before combat even began. Those figures turned Kummersdorf from an engineering lab into evidence of a collective mistake. According to Field Report No. 214/45, German frontline engineers compared, "The Panther needs engineers, the Sherman needs drivers." The line was quoted in the final report to the Armament Ministry. It was the simplest yet most bitter admission. In post-war debriefings, Speer ordered silence, fearing the collapse of industrial morale. But within himself, that line became a definition. German engineering built machines for the elite, American engineering built machines for ordinary soldiers, and that was what decided the war. In February 1945, Speer received the final report from the Western Front. Panther operational rates had fallen below 50%, while the Sherman still averaged 77%. The report stated, "We cannot sustain operations if every tank requires an engineer to start it." Speer did not sign it. He only wrote 2 words beneath. Zu spät. Too late. As Berlin descended into chaos in the war's final weeks, Kummersdorf remained active until April. In the workshop, Meissner walked around the old Sherman, now covered in dust. He placed his hand on the cold steel and said to Adler, "I think of that engine sound, the sound they call simplicity." Adler replied, "No, it's the sound of understanding." The war ended, but the reports on the Sherman remained in German archives well into the 1950 seconds. When Bundeswehr engineers read them again, they realized every fact had been recorded since 1943: durability, range, fault tolerance, ease of operation. But they had ignored it, believing something else, that the more perfect the engineering, the stronger it must be. The truth on the battlefield had erased that belief, drowned in the quiet roar of the Sherman. And in the dying days of the Reich, as the Panthers lay abandoned along the retreat, they said no explosion was louder than the collapse of an industrial faith. In the summer of 1944, when the war had entered its desperate phase, the numbers in industrial reports told a truth that no propaganda could conceal. According to the U.S. War Production Board, by June of that year, American factories had produced 49,324 Sherman tanks, while the combined total of all German tanks, Panzer IV, Panther, Tiger, and their variants still fell short of that number. Each Sherman was completed in less than 10 working days, on assembly lines coordinated by Ford, Chrysler, General Motors, and Baldwin, while each Panther required an average of 1,400 labor hours. In Germany, every mechanical failure was a small war within the factory itself, as spare parts were incompatible, materials were scarce, and workers were exhausted. At the same time in Moscow, the Soviet Lend-Lease Commission confirmed the receipt of 4,102 M4A, 2 Shermans powered by diesel engines. Red Army engineers favored this variant's twin GM 6046 engine, as it consumed less fuel and was less prone to fire in combat. They nicknamed it Emcher, a distorted reading of M4, and regarded it as the most driver-friendly of all Western-supplied vehicles. These Emchers rolled through mud and snow, advancing straight toward Berlin, while German units had to tow their own Panthers because of broken gearboxes. Inside Germany, the Reich's production system began collapsing layer by layer. On the night of April 27-28, 1,944 322 RAF Bomber Command aircraft bombed the Friedrichshafen industrial zone, home to the Maybach and ZF Friedrichshafen AG plants. According to Air Ministry Operational Report No. 12/44, the raid was described as a decisive blow to German tank engine production capacity. Flames rose hundreds of meters high, and the gearbox assembly lines were destroyed. Germany took more than 6 months to restore even partial operations, and product quality plummeted. The consequences lasted well into early 1945. The Panzer Commission report of January 1945, signed by General Wolfgang Thomel, stated, "Before the Vistula Oder offensive, the entire German tank force comprised 500 Panzer Force, 370 Panthers, 100 Tigers, and approximately 200 Hetzers disabled due to final drive failure, unable to be deployed. That figure represented 40% of all combat-ready tanks. Engineers reported that inferior materials, forced labor, and rushed assembly led to component misfits, contaminated lubricants, and many tanks being scrapped before leaving the factory. As one captured worker later recalled, 'We built tanks out of fear, not pride.' Speer received the report on the 12th of February 1945. He read each line in the narrow office of the Armaments Ministry, the yellow light casting tension across his face. Below the statistics, a line read, 'Technical failures account for 68% of total tank losses this month.' Speer underlined it and wrote in the margin, 'This is no longer a war of weapons, but a war of engineers against their own mistakes.' He summoned the directors of Maybach and Henschel, demanding immediate corrections, but all efforts were futile. Coal was scarce, power failed frequently, and skilled workers had been drafted to the front. According to the March 1945 production file, the Maybach plant operated at only 12% capacity, while ZF Friedrichshafen could no longer produce new gearboxes and had to reuse old components. Meanwhile, in America, assembly lines ran 24 hours a day in rotating shifts, and workers were rewarded for productivity. A War Department bulletin noted, "Each hour, the United States produces more tanks than Germany can repair." The disparity was no longer measured by engineering skill, but by organizational capability. In one final Armaments Ministry meeting, Speer looked around the room at the tired faces. He spoke in a low, firm voice. "We have won on paper and lost in the workshop." The secretary recorded the words verbatim in the 20th of March 1945 minutes. He continued, "We believed perfection was a weapon, but it only slowed us down. While we were still drawing, they were already producing." No one responded. The engineers who had once believed in the superiority of precision now only bowed their heads. Outside, the war still raged, but within German industry, the spiritual battle had ended. The Panther blueprints still hung on the walls as symbols of a once proud era. Every graceful line had become evidence of self-deception, proof that the Germans had turned engineering into a religion and forgotten that industry is a human discipline. In April 1945, as Allied troops entered Berlin, the engineers at Kummersdorf burned their remaining documents. Amid the flames, Meissner saw drawings of gearboxes, temperature charts, and the numbers they had once considered absolute. He said to Adler, "We had all the data to change, but we never learned." Adler nodded and replied, "Because we believed data could not change people." With air raid sirens wailing outside, Speer left the Armaments Ministry building for the last time. He looked back at the half-burned blueprints and whispered, "The price of perfection is collapse." And at Kummersdorf, amid the ashes of industrial idealism, Germany finally understood that a system that cannot learn cannot survive. The summer of 1945 left Kummersdorf desolate, like a piece of memory erased. The laboratories that once echoed with the hum of instruments now stood empty, papers scattered across the floor. When Soviet troops entered, they discovered hundreds of crates of documents, among them the 1943 Sherman test report, stamped Geheim, for internal use only. German engineers were forced to explain every figure. A Red Army officer said to Meissner through an interpreter, "You knew it was better, so why didn't you learn?" That question, simple yet painful, became the first cut into the pride of an entire generation of engineers. From 1945 to 1955, during Germany's reconstruction, the Kummersdorf archives were collected, classified, and transferred to the Bundeswehr's research division. Among thousands of yellowed pages, they found the once hidden notes. The M4A1 exceeds all German performance standards. Durability results from the acceptance of error. Standardized construction reduces repair time by 60%. Reading those lines, young West German engineers felt as if they were hearing the echoes of their predecessors, a belated confession of a simple truth. Engineering does not need pride, it needs efficiency. According to the 1953 Western Allied Technical Report, when German engineers were allowed to join NATO's rearmament program, they carried with them the first lesson of defeat: reliability over perfection. At technical seminars in Bonn, American experts reintroduced the production methods of the Sherman era: flexible assembly lines, interchangeable components, simple maintenance, and unified standards. What the Germans had once looked down upon now became the model. The original Kummersdorf files were used as teaching materials at the Technische Hochschule München, where on the blackboard someone wrote, "Simplicity is the highest form of industrial intelligence." By 1960, as the Bundeswehr launched its new tank development program, that lesson officially entered design practice. The Leopard 1 project, born in 1965 under Porsche and Krauss-Maffei, directly applied the philosophy recorded in the Sherman reports over 2 decades earlier. A compact chassis, stable transmission, synchronized gearbox, and standardized components allowed battlefield-level replacements. The 1965 Leopard test report stated, "Average mechanical endurance reached 3,000 kilometers before overhaul, matching the 1943 Sherman standard." For the first time since the war, Germany built a machine not to prove its genius, but to serve its operators. This transformation was not just technical, it was psychological. In the Bundeswehr Technical Academy, instructors repeated the Sherman story as an ethical lesson. They called it the Kummersdorf syndrome, The Disease of Engineering Arrogance. Students learned that design should not serve the engineer's ego but the user's need. In 1968, when the Leopard 1 entered service, many described it as Kummersdorf's repentant child. According to Defense Review November 1968, the Leopard 1 combines German engineering spirit with American industrial philosophy, allowing its engine to be removed in 2 hours and the entire drivetrain serviced in less than a day. Speer died in 1981. In his memoir, he wrote, "I learned that perfection has no value if it cannot survive in reality." That sentence reflected the quiet transformation of post-war German industry. The engineers who had once boasted in steel foundries now spoke of reliability, cost, and maintainability. In a 1970 interview, Heinz Lettmann, chief engineer of Krauss-Maffei, said, "The Leopard 1 is the first vehicle we built with the goal that it should outlive its driver, not that the driver must protect it." The story of Kummersdorf was retold in European engineering conferences as a classic example of systemic error. Images of the Sherman in the 1943 test yard were displayed at the Deutsches Technikmuseum beside a Leopard 1 model, beneath a small plaque engraved, "Durability is the highest form of creativity." Visitors paused, read, and understood that between those two generations of engineers lay a chasm of awareness from arrogance to humility. 70 years after the war, Germany once again stood as Europe's industrial powerhouse. Yet in every military design lecture, people still spoke of Kummersdorf, of the sound of War Daddy 2 that had roared in 1943. That sound, thought to have vanished in the ashes of war, became the rhythm guiding an era of rebirth. And at the end of the journey, history left behind a cold warning. An industry does not die for lack of invention, but for failing to stop at the right time. Kummersdorf fell, but in its failure, it taught the Germans what they had once denied, that endurance at times is the highest form of intelligence.